On this week's Carrier App, we speak with Michael Thelander from Signal's research group to get an update on the 5G standards process, as well as touch on the research firm's recent network testing of T-Mobile's 4x4 MIMO deployment. All right, well, thanks for joining this week's Carrier App. I'm your host, Dan Meyer, Editor-in-Chief at RCR Wireless News. And this week we are again joined by Michael Thelander, who's the president and founder of Signal's research group, to talk a bit about what's happening in the 3GPP, happening in terms of 5G standards, but also some work that SRG is doing in terms of some testing with MIMO stuff. So hey, Mike, thanks for joining us this week. We always appreciate it.
Glad to be here.
Very good. Well, like we kind of mentioned, you've been kind of our inside guy in terms of what's happening in 3GPP, in terms of a lot of the work on the 5G standards process right now. I know we're getting a lot of requests from people about talk more about the 5G standards, what's happening there. Again, it seems like we're still a ways away from actual standards, but it seems like right now there's a lot of behind the scenes work happening in terms of getting those standards in place. And so I know recently there was another meeting, I think in Vienna, Austria, kind of touching on what's happening there. So you guys put out a little report on it. We did a little story on it earlier, but I guess maybe getting you maybe some more insight from maybe what you, I guess, saw from that, or I guess kind of got from that meeting. Again, kind of your analysis of what happened there. Obviously, it does seem like still some progress in terms of the 5G standards. I guess, what's your view now coming out of that last meeting, and kind of as we are now in the 2017, what's your view on where we are in terms of that standards process?
Yeah, so I guess the big thing is that starting in March of 2017, and a couple months, 5G goes from a study item to a work item. So for all of the decisions that have been made so far in 3G or 3GPP, there's not necessarily a lot of meat behind it. So for example, they'll define, what the control channels will look like, or various, or the channel coding. But there's not a lot of detail behind that, So to kind of give the analogy, let's say you're trying to build a car, and you're discussing, okay, do we have a diesel engine? Do we have 4 cylinders? Do we have a gas engine, et cetera? Well, they finally decided, okay, we're going to have a diesel engine and 10 cylinders. But that's it. And so all of the mechanics of how you build the engine and how it all comes together, that hasn't been done yet. So for all the work that has been done in 3GPP, it's really still at the very beginning stages. A lot of the detail, a lot of the underlying mechanics of how things actually come together, that's yet to take place. And that will hopefully start, in the March time period. So right now what you have is kind of a last minute scramble, by all the various working groups to really complete the study item and then move on to the real work. So there's a lot remaining to be done. We'll see what happens. I think the other thing to point out too, and this is something I wrote about in the Signals Flash I put out in January, for the first phase of 5G, which is kind of release 15, it's really focused on one basic use case, and that's enhanced mobile broadband. So kind of the millimeter wave spectrum, kind of the multi-gigabit per speed data rates everybody's talking about. That's the real focus. The reality is, 5G is supposed to support a lot more in terms of massive machine type communications, ultra reliable, low latency communications, those types of things. A lot of the work on those other use cases really hasn't been begun yet. So for example, with massive machine type communications, 3GPP has already basically decided we're going to leverage LTE and narrowband IoT. And that's going to be how we're going to address those use cases for the time being. The other point that I made in the Signals Flash I put out in December is that, we're already at December. Very little work has been done on ultra reliable, low latency communication. So kind of the 1 millisecond latency and all those types of things. The work really hasn't started on that yet, in terms of the study item. So my view was, well, it's really not going to happen. It's not going to matter to most operators anyway. So why try to rush something to completion when it's kind of a half-assed type of thing, and it's not going to necessarily address the needs of the industry for the next couple of decades. So right now, within RAN 1, which is kind of the working group responsible for a lot of that effort, they're trying to address these matters. I think a lot of it's really more so the interdependencies between kind of the ultra reliable, low latency communications and the massive, broadband types, kind of the high gigabit type of thing, making sure that everything is future proof.
Mm-hmm.
I've seen, interestingly enough, one of the suggestions I had is, why even work on it? Why not just delay it to the next release like they have with narrowband IoT and massive machine type communications? Well, interestingly enough, I've seen some back and forth dialogue, at least involving one of the big operators, basically suggesting the same thing, arguing that, well, it'd be nice to have it in the first release of 5G, but the reality is no one really cares about it now anyway. Why rush it to market and develop something that's not going to really, meet the needs of the industry for the next couple of decades? So we'll see what happens. I mean, there's a chance they'll define something. I think even if they do, it's going to be one of those standards where the initial release of the capability is not going to be, fully capable of everything that it should do. Mm-hmm. So it's going to take, a follow-on release to really meet the entire needs of the industry on that.
Interesting. So then what it sounds like then is what's happening is people are kind of focusing, at least initially, on the fixed wireless, types of solutions, basically the enhanced level broadband. And that part there, again, doesn't need kind of all these new, all the additional enhancements to it. So basically, like release 15 we're looking at is basically going to be just a fixed wireless type of solution.
I wouldn't necessarily call it fixed. I would say it's mobile as well. So you can have the mobile devices, but it's going to be, kind of the high millimeter wave, frequencies, or even lower frequency bands. But again, really focused on just really driving up the bandwidth, increasing the throughput, not so much on supporting millions of devices, IoT for everything, and not so much on having really low latency, ultra reliable communications. I think that is where there's going to be not a lot of effort for the time being, both from 3GPP, but also in terms of operator interest.
Interesting. I know we've seen recently kind of a lot of operators come out, basically kind of touting where they are in terms of end of the year type of a network work in terms of, LTE or whatever their 5G kind of plan is. And, a lot of them are talking about, they're getting close to gigabit speeds now with basically enhanced LTE is what they're looking at, LTE advanced for the most part. And also some latencies down to 2 or 3 milliseconds. But again, that 1 millisecond kind of goal, it seems like, as you try to get lower and lower, it becomes more difficult to make that kind of, to kind of reach that goal. So it does sound like those are still, obviously goals to have, but they're going to take a while to kind of get to what the true 5G that everybody's kind of talking about at this point is going to be at some point.
Right, because there's basically two things required to get the very low latency, in both LTE and 5G. Yeah. And of course, obviously there's the air interface. So in LTE, you have a 1 millisecond subframe, and that's kind of the amount of bandwidth or the time interval where data is inserted. Mm-hmm. The problem is that if it's only 1 millisecond, that's kind of your defining boundary in terms of reducing the latency. So now there's something within 3GPP, within LTE called short TTI, and that's taking that 1 millisecond subframe and making it much shorter. Mm-hmm. So when you do that, you can actually take your latency in an LTE network to the single digits in terms of milliseconds. The other thing you need is you need to have your applications very close to the edge of the network. Yeah. Now, for example, you can have very low latency in the air interface, but if you're connecting to an application on the opposite end of the country, you're still going to have very high latency because of just the speed of light. Yeah. And all of the backhaul of the transport. So you also need to move whatever application you're talking about very close to the cell site. Well, that's your whole mobile edge computing and whatnot. That can be done on LTE or 5G. The problem is that's very expensive to do. So it's not a 5G or a 4G or a 6G concept. It's a matter of economics. Yeah. How do you do that, and what applications do you move to the edge? Where's the need for those applications? What's the business case? All those types of things. And that's going to take a while to happen, regardless of solving the problem in the air interface itself or the network. It's moving that application very close to where the consumer is. And that's really a matter of economics to address and not so much a technology issue. That's going to take a while to solve.
Yeah. Not to make this an economic conversation, but you're right. It does seem like at least the initial focus on whether it's fixed or mobile type of an enhanced broadband service, that does at least seem to have some sort of business case behind it, I think, for the operators. And so that initial focus on that probably for them makes sense financially. Like you said, there's other things that are coming down the road. The business case, use cases for those, while they're perhaps being defined now, they still seem like they're kind of down the road a bit in terms of how operators can actually monetize the costs that would be associated with rolling out those enhancements. Those, like you said, those are big investments on networks that are still costing operators a lot of money to run. So
Right.
definitely save some money there if they can, at least in the short term.
And it's also important to know too, within LTE, with the short TTI, that work item should be completed by September of this year.
Okay.
So what that really means is that you're going to have the much lower latency feature available in LTE much sooner than you have it on 5G. And I think in that case, going from kind of a theoretical, 12, 15 milliseconds to say 4 or 5, maybe 8 milliseconds on LTE, there you're going to see some performance benefits in terms of kind of other applications that don't necessarily require ultra low latency.
Yeah.
So I think there you don't necessarily need to have all of the applications at the edge of the network to see some of the benefits. But I think when you start talking about going from that level to 1 millisecond, making it ultra reliable, et cetera, the heart monitor and whatnot,
Yeah.
That's where I think it's going to take some time to address not only the technical aspects, but also the business case.
Got it. And then a quick wrap up then, I guess, on the fact of the timing aspect of all this. So like you said, the next, I guess, major waypoint on this is the March timeframe, where we'll have all these things kind of set, at least kind of set in stone, or at least a model of it set in stone from 3GPP, that the operators can then, I guess, start using that as kind of their model to then kind of fill in the pieces, kind of put the pieces to the engine together as you work forward to an actual 5G type of standard, which I think we're still looking at probably a mid-2018 timeframe at this point. Do you think for some sort of official standard from 3GPP?
Well, that's definitely the milestone. I mean, there's still talk about accelerating some of the various options, and they talked about that in Vienna. They talked about that back in Gothenburg. They talked about it in Busan. So that keeps coming up. It keeps getting beat down.
Yeah.
So I think there's also the opportunity in March, for those operators that want to accelerate certain features within the 5G specification, they'll have their chance again. And so I think probably the earliest would be December, I guess, of this year, or perhaps March.
Okay.
Where you'll have, certain aspects that would allow them to deploy, a different type of architecture or one facet of what 5G can do to kind of meet their needs. And then by June of 2018, I guess, kind of the first full release of 5G would be done.
Got it. Okay. Well, then I guess before we get off this topic of the 3GPP meeting, one thing I know you wrote about as well was the fact that it seemed like that the new radio designation has been Ticular Curve, and now we're going with 5G now as the official designation. Is that kind of what came out of that meeting?
Who knows? I mean, I think that there were some decisions that were made at the meeting, and I think after the fact, based upon the various email threads, some people rather changed their minds or they weren't at that meeting, and so now that's being kicked around again. It's kind of interesting. In reading some of these emails, they go back and forth. I mean, I think 3GPP recognizes that they're a bunch of engineers and they're not necessarily well qualified to come up with a nice acronym. LTE kind of did its stuff, but even then, I mean, I think some people argue nobody really knows what LTE means as a consumer.
Yeah.
What is 4G versus 3G? I think people know that 4G is better than 3G. 5G is probably better than 4G for whatever reason. So, just calling it 5G has some benefits. The other aspect of that is there's a lot of nomenclature within the 3GPP specifications, referring to various nodes and interfaces, et cetera. There, I think it is important to have some very well-defined acronyms for these various terms, because when you're writing specifications, people really need to understand, okay, if I call it an E node B, or I call it a G node B, or whatever that nomenclature is, knowing exactly what it can and cannot do without having to define it all. Mm-hmm. So there's a lot of discussion there as well. doesn't necessarily impact anybody outside of 3GPP, but it's definitely something that needs to be resolved, in the near term to allow them to really start developing these specifications. But either way, when you talk about 5G, again, it's important to understand 5G is not just a new air interface. Mm-hmm. Ultimately, when 3GPP makes their submission to the ITU in 2019 to say this is our 5G solution, that will include many elements of LTE. Or LTE Advanced Pro, etc. But based upon the air interface that exists today, that will be part of the 5G standard as well, not just this new air interface.
Interesting. Yeah, I guess we have to get the marketers on this at some point to kind of come up with a nice catchy name for it. Because I'm surprised that LTE actually lasted as long as it has as the actual name for this technology. I mean, I know when LTE first came out as a name, I was like, there's no way that's going to be what they're going to call this. It just seems like such a technical term for it. Why would they do that? Obviously, from the technical side of things, it makes sense. But from the consumer side of things, that just seemed like such a crazy thing to do. I mean, to me, WiMAX made more sense as a name than LTE did, only because it seemed, faster.
WiMAX was a great name.
Yeah, I mean, it's got Max in it. Anything with Max in it is a great name. So that's key. But you're right, LTE was just such a weird one to go with. But again, maybe if it's just 5G, maybe
let's call it LTE Max.
There we go. Let's do that. That's boom. Copyrighted.
Problem solved.
Let's just do that. So I guess I'll figure something out at some point on when it comes to the naming part of that. But well, interesting topic there. I guess at least get an insight on what's happening with 3GPP. But another topic I wanted to discuss with you was, I know you guys are always doing constant work out in the field, testing different technologies, different devices, different enhancements to the network. I know one of the recent things you guys are starting to do is some testing on the 4x4 MIMO technology in the network there. I guess you talk a little bit about what's going on there in terms of your testing there, what you're seeing in the network, I guess performance-wise in terms of, I think it's T-Mobile and their 4x4 MIMO testing.
Yeah, so I've been doing testing of T-Mobile's 4x4 network. Later this month, I'll be going down to Australia, where Telstra has already launched their 1 gigabit per second LTE network. So we'll see. There's a lot of talk now, operators in the U.S. about launching 1 gigabit per second LTE this year or next year. Yeah. Well, that's already been done in Australia. So I'll know in a few weeks, how real that really is. But I can say, 4x4 MIMO, and a lot of things that T-Mobile is doing are pretty innovative, and definitely there is a significant performance difference based upon all the various features that T-Mobile has launched. So it's not just 4x4 MIMO, which is one thing. There's also, 256 QAM modulation, so getting a higher modulation in the downlink. Yeah. They're the only operator in the U.S. to have done that. There's uplink, 64 QAM. Again, definitely improving capacity and throughput in the uplink. And finally, there's the device itself. So with 4x4 MIMO, it really takes two to tango. So it's not just an upgrade on the network side. It also requires an investment on the device side. And so one of the features there is basically a four-way receive antenna architecture, which provides a lot of benefits even in the absence of 4x4 MIMO. So kind of summing it all up, based upon the testing that we've done, if we compare two devices on the T-Mobile network, one device that supports all of those features, another identical device, same manufacturer, the Samsung Galaxy S7, without those features, we're seeing in excess of a 50% improvement in performance in the downlink.
With the same amount of spectrum being used? The same,
yeah. So our testing was limited to band 4, which is the AWS spectrum. Yeah. And so this is filtering out, all those cases when you may have two devices on a different cell site, which happens, during a drive test. Yeah. You factor all of that out, and we're seeing, a 50% or more increase in throughput on average. And that's significant. And of course, the benefits are due to all of the various technical features, that T-Mobile has implemented. It's just that on the second device that we tested, that device lacked those capabilities. So the device itself could not benefit from what T-Mobile has done. You could really kind of extend that to other networks in the U.S., operators that haven't deployed those features as kind of an analogy for what T-Mobile has done vis-a-vis the other operators. So I think that the point here between what T-Mobile has done what I expect to see down in Australia in a few weeks is that LTE Advanced, LTE Advanced Pro, etc. There's a long life there. Yeah. And there's a lot of things operators can be doing, device manufacturers, chipset manufacturers, etc., to really get a heck of a lot more in terms of performance out of their LTE networks. It's not being done. So it's fine to talk about 5G. It's fine to talk about 1 gigabit per second LTE. But even excluding those two things, there's a lot that can be done that I think operators aren't doing. And so they can point to 5G as kind of like, okay, well, LTE failed us, and now 5G. And so kind of biding time, if you will, for the next few years. But I don't believe that. I mean, they're definitely missing the mark if they're not doing a lot of the things that some of these operators are doing today in their networks.
Yeah, and that kind of concerns me a bit, because you're right, it does seem like our operators are in such a rush to be touting 5G progress. But you're right, this LTE network still has so much capacity and capabilities embedded in them if operators want to actually tap into these resources that, this move to 5G, well, obviously it's going to happen at some point. There's no need to kind of throw out the baby with the bathwater. I mean, there's so much still available for these operators. It's just a matter of them dedicating the resources, I guess, to doing it. I mean, again, for T-Mobile, they do have one of the newer LTE networks out there, so perhaps it was an easier move for them to do it. But still, this stuff is in the specs. It should be something that can be upgradable for these operators if they want to go down that route.
Right, but it's expensive to enhance your network. Yeah. It's very cheap to go out and do a field trial and market the fact that in 3 years you're going to have 5G in your network. That's cheap to do. It's a little bit more expensive to actually make the investments, to upgrade your existing network or devices to support, these capabilities and features.
And again, when you see these enhancements, these aren't just, I mean, the speed part of it is impressive, but it seems like the spectral efficiency enhancements for the operators is kind of the key, because operators, while they do have maybe some spectrum bands here and there that they can kind of unleash on these services, kind of some clean spectrum, spectrum is still a bit finite resource, it's a finite resource. So obviously, whenever they can get some sort of efficiency out of their networks that they have now, that's going to be a key part of their reasons to kind of go down these roads of enhancements.
Right, and I think that was the big thing, when operators went from 3G to LTE and now going to 5G, in terms of the performance gains that you're going to see, part of it's obviously the new air interface and it's better. But a lot of it is you're deploying, new spectrum that's unused. Yeah. And so you go from a fully utilized 3G radio channel that's doing, HSPA plus or dual carrier, and now you go to LTE, in the 700 megahertz spectrum, for example, that operators used back then. Mm-hmm. There's no consumers there. There's no traffic. So you're basically in an empty network. Any technology today, 3G, 4G, et cetera, an empty network, it's going to perform, very well, assuming the operator did a good design of the network. But you're right. The problem is, with LTE networks today, they're starting to see a fair amount of traffic on them. So a lot of these features, going to higher modulation, more advanced antenna schemes, using carrier aggregation to really optimize all of the channels to kind of, move traffic around as necessary to take full advantage of the spectrum resources that are available. Those things are really important.
Yeah, interesting. Yeah, I know for myself, I'm holding on to an old 2G device because I know at some point here, all the customers will be off of 2G networks and I'll be the only one on that 2G network. And I'm going to get like some crazy 100 kilobit per second speeds on there. I'm going to be very excited about that. So I'm holding out for that happening one day.
And the other thing is that if you're a subscriber for AT&T, they're probably going to come back to you and say, here's your free LTE phone to get off the 2G network.
That's right.
Yeah. For you too.
Yeah, you hold out, you get the best deal. So that's always like right there. So I know we have one more topic I'm going to cover with you really quick. But before I do that, I have one kind of off-topic question a little bit. And that is, all this talk about the millimeter wave spectrum being used for 5G and different services. I mean, what's your view on the use of millimeter wave spectrum in a commercial deployment? I know we've talked a little bit about this, Nick, in the past. But, I mean, all these bands that are kind of moving up the ladder there, it seems to me that we're going to be getting some really tricky deployment models where any sort of interference, whether it's a leaf or a piece of paper or something, is really going to impact what happens with these networks. Are you hearing or seeing any concern in terms of these initial trials about kind of what millimeter wave spectrum is able to do in a commercial deployment?
Yes. So two comments there. First of all, with the higher frequencies, the advantage there is that the size of the antenna is greatly reduced, and so there you get a lot of gain from beamforming. So people always talk about, well, the higher frequencies won't radiate as far as the lower frequencies. Well, that's true, but now you can throw more antenna beams at the problem, and that can make up for a lot of the loss that you get from the higher frequencies. But the other point is that, this whole concept of trials with millimeter wave spectrum are just starting to take place.
Yeah.
Within 3GPP, they have the so-called channel model that allows them to kind of simulate or estimate what performance will look like. Well, that's a very important thing because they're now defining the 5G air interface based upon that channel model. I think that the challenge there is that they've really rushed through the channel model. And there's a lot of concern on my part based upon various conversations that they probably didn't necessarily do the best job in defining the channel model. The problem is we don't really know. And so they could be making all of these decisions that they think are optimal, but it's based upon a channel model that's not accurate. And so we'll see what happens when you get out into the network and how these signals actually bounce off or don't bounce off or kind of angle off of buildings. How the hand impacts, if you're holding onto your device, how the hand impacts performance if you turn around as you're talking on the phone or doing a data session. How do the beams follow you? All those types of things I think are very important, and we're really not going to know until after the fact whether or not we did a good job.
Got it. Okay. All right. Very good. Well, I know, again, one more final topic we'll touch on here, and I know you're fighting a cold there, so I appreciate you staying on a little longer for this year, but I know you guys are doing some work in terms of some 5G training, and I think that's a pretty important topic because I think people are, again, very interested in this topic, but aren't quite sure how to kind of tackle what is 5G. So I don't know if you want to talk a little bit about what you guys are planning on doing and kind of what the model that you guys are going to kind of have in terms of this 5G training program. Right.
So this is a training program. It's really designed to be an online training program, so you don't have to travel somewhere, or we don't have to travel to you, although that's obviously an option to do that. But it's really designed, for companies or individuals to basically purchase licenses. You can sit at your desk at home and kind of watch these sessions online. But there's a whole number of different modules that we're putting together, various aspects of 5G. There's also something on IoT, and this is actually a collaborative effort. So we're working with 5gcourses.com. That's the website. You can go there and check out all of the various modules that are available now or will be available in the future. But it's really designed not so much to teach people about kind of what's happening in 3GPP. It's really more designed to kind of give a very good understanding of what 5G is. What are the use cases? What does the air interface look like? How does it differ from LTE? Looking at the network itself and understanding the various elements, network slicing, software-defined networks, et cetera. All those types of things. So it's really, it's somewhat engineering, but it's designed really for anybody in the telecommunications industry that really wants to appreciate, what 5G is all about. So you can kind of check out, it's talked about on our website a little bit, but we'll probably point you to 5gcourses.com for basically a better understanding of what all these modules are about.
Interesting. Yeah, it sounds like a good timing for it too, because again, people are very interested in this topic and aren't quite sure kind of how to approach it. I think in some instances. So it sounds like a pretty good way to do that. And again, I know going forward here, I know some of our conversations that we have going forward, we'll talk a bit about some of those modules a little bit more in depth too. So for those who are watching now, again, kind of make sure to check back with some of our future interviews with Michael and other people at SRG, and we'll talk more about these modules as well. But Mike, we definitely appreciate the great insight on the topic today. Obviously, a lot going on in terms of kind of the timing for 3GPP, working on 5G standards. I know, again, March, we have another waypoint coming up, so we'll see what happens there. But again, we always appreciate the time and insight, and hopefully we'll talk again soon on the topic. Well, thanks for watching this week's show, and make sure to check out our next Carrier Wrap when we speak with Dan Hayes from PwC's Strategy and Division to discuss the impending inclusion of the FCC's 600 megahertz incentive auction and get an update on 5G deployment plans and challenges.